So I want to introduce you to someone you don't introduce, but the only thing I could say, apart from all his function at the UM6P, like he's the director of the biggest college of the UM6P, agriculture, and he has so many projects. Yes, many projects, specifically like the House of Atlas and other things like that. But he has a specificity. I think is the only one, and maybe the one that has mostly his feet on the ground, like at the UM6P, like really on the ground, in the ground also, because it's part of his function. In French, we say les pieds sur terre. He is really the one that has le plus les pieds sur terre at this university. And so we are welcoming him at our monthly seminar of the Chair of Transition, which is, of course, located inside the Institute for Advanced Studies, but it's really the monthly seminar of the Chair of Transitions. And so he will talk to us about transitions in African agriculture and some ideas and groundbreaking ideas. Groundbreaking ideas, I mean, on both senses.
Thank you, Raphael. Thanks for the compliment also to be grounded. I think it's important to be grounded.
You really are.
And it's also important to be aware of the context. And that's a bit the message I'll try to give during this presentation. That's a presentation I slightly adapted from a presentation I gave to the School of Collective Intelligence. And more people are talking about wicked problems. And I think agriculture and food security and agri-food systems are typically sectors where you have wicked problems. So, what is a wicked problem? A few characteristics of wicked problems. There's no clear definition. So, usually scientists like to define. And for wicked problems, it's difficult to define because the nature of the problem and the boundaries of the problem are difficult to define and draw. And your perception of the problem might depend of your own disciplinary field or your role in the ag systems. That means that they are often, on wicked problems, there is stakeholder disagreement. So people see the problem differently, and they usually see the solution of the problem differently. Because different views, values, and interests. So multi-stakeholder, you have different interests. The interest of a farmer is not the interest of a middleman going to the market with the farmer's product. It's the contrary. Unintended consequences is also something very important. Very difficult to predict what an action on a system will lead as unintended consequences. Sometimes economists call it externalities, that when you create something that has consequences outside of your systems. We'll have an example of unintended consequences. I just mentioned Africa, but I have quite a few examples from my previous work at CIMMYT, and it includes also some example in South Asia and also Latin America. It's interconnected with other problems. So when I was mentioning the context, it's not just looking at a problem in isolation. Usually engineers, what they do, they deconstruct and reconstruct, and sometimes with wicked problems, you cannot do that. Unique context, of course, and no trial and error. Usually the problem is so large that you cannot design an experiment to see, oh, if I do that, I will get that. That's what usually empirical science is doing. It's not a new concept. In fact, the term wicked problem was first defined by two scientists from Berkeley University in the 70s. And I will not spend a lot of time. Of course, I can share the presentation. You can go to that original paper in 1973, but you can see the property of wicked problems here. So the message of this talk is that wicked problems resist simple fixes and require collaborative, adaptive, and system-based approach rather than technical one-size-fits-all. And very often in universities, we have people with disciplines, with specialties. Very often here, AI will solve the problem of African agriculture. How come? How come? I wonder. Drones are fantastic. They will solve all the problems we have in trying the right fertilizer for the crops and managing the risk and so on. not like that. So also a message that agriculture is not a science. Agriculture is a sector, and there are many, many scientific disciplines. And it's often very difficult to connect those disciplines in a meaningful manner, because scientists have their field of expertise, and they usually rather collaborate with people thinking and knowing what they know than collaborating with people thinking totally differently. And I think you can go to all that. It's more related to plant science, animal sciences, but basic science as well, like mathematics, chemistry, physics, atmospheric science, but also a lot of social science, very important. Sociology, anthropology, business, psychology, policy and law, economics, data science as well, which is something that's becoming more and more important in what we do. And only, Jacques Wery was here. In fact, he's leading a community of practice on systems research. He's coming from Institut Agro in France. And we were together here exactly a month ago, Jacques. And we had a very interesting discussion. So now we can collaborate between disciplines. And it's not that easy. Even between economists and agronomists, it's not easy. Who knows that famous picture? What does it mean to you? Yes, Fouad.
It means that everybody sees
what he wants to see.
From his own discipline.
Yeah, exactly.
Everybody needs classes.
And everybody needs to zoom out also. Zooming in and zooming out is something very important, because you have the nose on, and that's why I'm calling myopia. And that depends on your entry. You might not always be linked to disciplines. You are working on a problem, and if you enter by the front of the elephant, where you think it's a snake because you see the trunk, you see the space. So I think it's a very, very interesting way of representing the disciplinary, the monodisciplinary approach as well. I will not go through that in very much detail, but there's a very strong multi-sectorial nature in agriculture. It's linked to natural resource, health, nutrition, education, capacity building, economy, infrastructure and technology, environment and climate change, and very important is policy and governance. Because the knowledge you generate, can reach impact at scale. While if you work in a very narrow discipline and working on new fertilizer formulation, your impact pathway is drawn. You are paid by OCP to do it, you come with another product, you test it, and up it goes to the industry. But most of the problems are much more complex and more wicked than that, and then you need to go, usually the knowledge you generate needs to go through the policy arena. The context matters, and I think we talk a lot about African agriculture. And sometimes I hear figures that, Africa can be food secure. Africa can feed the world. At which cost? Because it's usually very simple figures. I think Africa has a lot of still arable lands, but have a lot of degraded land as well. So we have to be careful about those statements. But two major drivers of change in African agriculture is the demographic pressure. We are 1.5 billion on the continent today, will be 2.5 billion by 2050. Huge increase. And something else is that if you look at the structure of the population distribution, we are 40% in cities right now, and projection says that we might be 60-65% in cities by 2050. Major change in the way food is produced, food is consumed, and a lot of environmental challenges linked to that. The other thing that's striking about Africa, active population involved in agriculture in Europe is 2 to 3% maximum, the same in the US, the same in Australia. Africa still employs more than 60% on average of the active population, with country really almost depending uniquely on agriculture. But Africans are farming, but the first objective of farming is to feed themselves and to feed their family. a lot of farms are still subsistence farm with more and more commercial orientation. You can also imagine what the demographic pressure does on farm size. If you don't have job opportunities outside and you still have such a large number in farming, fragmentation of farms. And in many places in Africa, we reach a point that with the fragmented farm size, increasing fragmented farm size, we don't have enough to feed the family even. We cannot provide proper livelihood. You cannot lift people above the poverty level. And there are very interesting stories about that. So again, agriculture is very important from Africa, but agriculture alone will not save Africa. You need the development of the secondary and tertiary sector. You need to increase the value addition of agriculture. And right now, very difficult because you don't have value chains developed and so on. So if you produce more, sometimes farmers have problems to even sell their products. And you have also the variability that you have between years in terms of production. So very difficult to size ag transformation industry. For example, if you produce tomatoes and you build the canneries and the farmers around you produce X 1 year, 4X the next year, and X divided by 2 the third year, how do you size that canning industry? And you know, very, very often, I mean, when I was younger, I was working in Niger and I traveled to Burkina Faso. Everybody thought that tomatoes were great. And at the time of peak production of tomatoes, all the tomatoes were in the gutters in the city of Ouagadougou, the capital of Burkina Faso. So you need, in fact, and that's wicked, because you need not to have sequential action. Let's say, well, let's use fertilizer, let's produce more. If you produce more, let's develop the value chain. Everything needs to happen at the same time. Low return of labor, also very low labor productivity, and that's again a chicken and the egg. You know, people say, "Oh, it doesn't matter." You know, people depend on agriculture; they have plenty of time. They should, you know, this is not true because it's a catch-22 type of thing. And we have studies now. When I was working in CIMIT in Bangladesh, that the quality, the gender positive effect of mechanization on women and the care they took for their children and the free time they were getting also. So that's also something we need to look at in a systemic fashion. Urbanization, and I think you have been in some big African cities coming from Nigeria. Rwanda is a bit more planned, I guess, no? Kigali is a nice, well-organized city. But you have big cities in Africa, and it does include Morocco as well. And it does include sometimes cities in Europe. I mean, I think some cities in Europe are not really livable. And it's probably something we want to work more on, because it's, in terms of a systemic approach, cities are very interesting. And there are areas of opportunities. So I will not go in detail to that, but there was an FAO report 2 years ago about urbanization, and you can really see how things are linked in that very simple scheme. But that's the type of diagrams that we have to look at if you want to look at synergies, trade-off, unintended consequences in systems, and potential solutions, of course. So I will skip that one, but that shows, in fact, no, I will not skip that one. The annual fluctuation you have in crop production in several African countries. And you can see that for cereals, rain-fed in Morocco. And we all know in Morocco that there are years where we have to import a bit, and years where we have to import a lot more. But that's planned. In Morocco, it is planned. And you can see that sometimes low yields, but more stable yields. So when you look at criteria to assess agriculture, whether you look at yields or you look at stability, and you have totally different ways of looking at things. That's a yield gap map. That shows everything in red means that we are producing much less than the potential. And there's potential in rain-fed systems. And you can see the distribution. But you can see that nobody is maximizing yields because the economic characteristic to that, you know. Filling the yield gap is usually not economical, but there is potential to that. And again, we know that crops respond to fertilizer, but that's just one part of the solution, because usually fertilizer are not physically accessible for most African farmers. Farmers are using 20 kg per hectare per year of fertilizer, while in Europe we use 250, 300, Brazil 600. Yes, Fouad.
In what sense is it not sustainable?
Hmm?
You say most farming systems in Africa are presently not sustainable.
Yeah.
In what sense are they not sustainable?
You take the definition of sustainability. It's 3 pillars. It's economic, social, and environmental.
Yeah,
And usually you don't have the intersection of those 3 things. Because the social bit, you know, the function of agriculture is first to feed people.
yes.
Second is to make people a bit more wealthy than they are. And it's not to harm the environment. Yes, and then you have a soil erosion because you just extend your crops to marginal land and so on. You cut forests to get croplands. I mean, all those type of things. And the economics is not there. I mean, what I was mentioning, no value chain development, that's very difficult to develop because the risk management for the farmers, but also for the private sector is usually large. And there's lack of investment. You probably heard about planetary boundaries, and I will not go in detail to that. But most of the planetary boundaries that are beyond the safe operating space are either linked to transport or to agriculture, or to both. So you can see that everything is quite worrying. Land system change usually is driven by agriculture. Freshwater change can be linked to agriculture as well. In Morocco, we use 87% of the fresh water for irrigation, and we're starting desalinating water as well. Geochemical flows, phosphorus and nitrogen, is also agriculture. Biosphere integrity is also land use change. Climate change, it's transport and other things. So we can see that we are still okay with the aerosol and the stratospheric ozone depletion, which was a problem 40 years ago. It was sorted. I will go through that very quickly because I made a longer class for the School of Collective Intelligence, unless Fouad wants to look at some of those things. But it's about the research methods. Again, people, when they are not in the field of agriculture, don't realize the richness of the tools and the analysis we are doing. So, but we have basic field experiment and trials, and that we have been doing that for a very, very long time. And then, again, you can say one trial will answer all the problems, but not for Africa. It will answer the problem for the location in which you are, for the year you are. So it's very important to think when you do experiments that you are designing your experiments, that you get the most information, the most valuable information possible. The discussion of whether you work on farm and on station, and it's usually when you have different questions. I worked a lot on farm, but on the farm you have control trials with farmers, and you can have experiments with farmers where they design the experiments themselves, and it's totally different purposes. Long-term experiments are important because they validate some of the assumptions we have about, for example, carbon sequestration in agriculture. I think people here are over-optimistic about the role of agriculture in storing carbon, especially with conservation agriculture. And I think as a university we should be, critical of that and questioning that, because we have people building business models that are not built on science, and I think we shouldn't do that. So you have all those type of designs and so on. We have also the socioeconomic bit with household survey, and of course we have now more and more data with UAV, satellite imagery and so on. So a lot of things that we can do there. We have analytical and computational methods. So the statistics, of course, econometrics are very interesting. Multivariate analysis, modeling, a lot of different sort of model. I mean, people, when you say modeling, they usually think in agriculture of crop grow model, but you can model many, many things. like the systems dynamic model, agent-based model, which are more in terms of, social dynamic. They are very interesting to use. I use a bit of them when I was in Niger. It's quite difficult to validate, difficult to calibrate, difficult to use, but sometimes they are very useful to look at emerging properties. So things that you cannot see in a complex system that emerge from intervention or from the normal evolution of those systems. Crop model, livestock model, life cycle assessment, very much used in climate change, just to look at the real footprint of something, a product or an action. Integrated assessment models. So a lot of also participatory and transdisciplinary methods. Decision support and policy analysis. Qualitative and mixed methods approach. So mixed methods is usually when you use both quantitative and qualitative methods together, and really it's a science and an art to do that properly. Delphi is a very interesting, Delphi.
What is Delphi?
Delphi is just looking, it's a method to look at expert knowledge. Though sometimes you want to know something about a problem. If you go randomly and talk to people, but you might get a very, very mixed message about the problem itself. So Delphi is, looking at experts. So it's experts consultation. It's a method to do that. So instead of randomly selecting people to ask them questions, you just go to experts, and you try with Delphi to get contrasted experts' view, because you remember the stakeholder, a different vision of different stakeholders is also something that can be useful when you use Delphi methods. Remote sensing, I use it a lot, it's fun, and it's really becoming more and more important, because in environments like Africa, where you don't have data for everything, very important to get proxies of things. So remote sensing can be quite interesting. Systems analysis, we are at the beginning of that, I think. Artificial intelligence and machine learning, I think when you process large amount of data, images and so on, it can be very, very useful. And it can also be misleading sometimes. So you need to know what you do with that. Of course, the evolution in agriculture, you have space and time. So the temporal nature of things is as important as the spatial nature of things. Jacques, you want to explain? Because that comes from your... I will skip that one, but that's a conceptual. I mean, it's a conceptual way of looking at problems, but it's a framework that, in fact, shows the dynamic of you start in one, but you loop all the time. Jacques, do you want to say a few words about it? Because it's.
Well, the idea for this community of practice that we are trying to set up was to have a framework where you can put. Not the precise methodology, but the type of question you are raising on the system. For example, when you want to assess a system, it means that even if it's a complex system, you don't try to understand how the system functions. You want to assess on different criteria, for example, its sustainability or its resilience. So you just select indicators that are characterizing environmental footprint, social footprint, and you analyze the system just for this, and it's generally to compare different systems among them, or to compare them to an objective. So just to give an example, the last part is more the design part, where you want to redesign, because in agriculture generally you don't start from scratch. You already have a farm, you already have a soil. So if you want to have a real transition to our agroecology, for example, you need to redesign the system. So to think a new system and to test it with different methods and to assess. So this is both, it gives a major aspects of systems science, and also the link that can be made with them. Before assessing a system, you need to define it. You properly define the boundaries and how, from a problem to a system.
Thank you, Jacques. The level or scales at which you are looking at things is very important as well, and you have nested levels in systems. You can start with the molecule, the cell, the tissue, the organ, the individual, the population, the ecosystem, the biome, and the global. If you translate that more in agricultural terms, you go from plant to animal to field, herd, farm, village, landscape, country, and global. And of course, you have cross-level interactions. Something that might appear as a synergy in one level might be, in fact, a trade-off at another level. So whether you look at the farmer level or the landscape level, you can have totally different visions of what is good and what is not good, if I can use the term good. So talking about good, many people assess performance in systems in yields. It's like a bit like the grade of your exam. That's the standard way of measuring things. But productivity is not the only desirable things in systems. Efficiency is very important. Labor efficiency, I was mentioning. You might have less yield, but having a higher labor return on investment, so having more money by doing that. The same for phosphorus and nitrogen. Nitrogen use efficiency is very important. The stability, that means that you have some systems going down, decaying. If you look at stability of the groundwater in Morocco, it's going like that. It's the red line. And what you are looking for is a blue line. Reliability, and that's the internal variation you can have for many different reasons. So it's much easier for an industry, food industry, to work on a high reliability than a low reliability, just to size, all the factories, the transformation factories, and so on. Resilience is sometimes understood differently by different people, but it came from physics, and maybe Fuad might say it comes also from another field. But resilience is the property of an object to go back to its original state after deformation. So a spring is really resilient. If you take a wooden stick, it's not resilient because it will break. You try to deform it, and then you have different things. So you can be resilient and have very low productivity, have very low efficiency, have very low stability. So that means that you usually need to look at those criteria in a multi-criteria type of analysis. So adaptability is when you have abrupt change to things. It's a bit like the resilience, where you have a shock, but you recover from the shock there, and there you go to another state. Sometimes people call it tipping point. So you go from one state to another one, and you cannot go back to the previous state. So it's a tipping point. That's what we are living now with climate change. We are reaching many, many tipping points. I will go over that, but that's one of my colleagues from CIMMYT, who is now with CIRAT, and that's just a way to show a conceptual framework to look at a complex system, farming system, and the interaction you have at different levels. Of course, when you do that, after that, you need to have an operational framework to be able to do some modeling work or simulation work, put your data there, and so on. But it's usually very important to go to a conceptual level before you start crunching things and numbers. And you can see that there are always boundaries in your analysis. You cannot analyze the universe, so you have always boundaries that you need to define. Another person from my former team in CIMMYT worked a lot on typologies, and that's based on the fact that one farmer is not the same than the neighbor farmer. There are very many different. So when you are looking for solutions in farming systems, don't think that one solution will fit all farmers in a given village or in a given landscape, even less on the African continent. So when people come with magic silver bullet, you have to question, is this really something that will be useful, adopted, and adoptable by farmers? So that's the typology, I think, in India, and showing that different farm types have totally different energy sources, and they are in the same district, I think, in India. So, of course, there are some farmers more interested in livestock production technologies, other more in crops, certainly some in value chains development, some are more in subsistence type of farming. So very important to know your customer when you come with interventions in system. And of course, you can do beautiful, principal component analysis. You can use spider diagrams to look at trade-off between different aspects of your system. The same way to represent typologies, and in typologies you have structural typologies and you have functional typologies. Structural typologies, how large is the farm, how many animals. Functional typologies are more in the flows of labor flow, biomass flows, all those type of things. And in our analysis, we usually look at both the functional and structural typology, and looking at resource allocation strategy, which can be labor, which can be cash finance, can be other types of social capital as well. Sometimes it's looked in those systems. That's been a paper from one of my team member in CIMMYT, very young scientist, but very good with data. And I think that's one of the first paper we tried to define what we call food availability index. And looking at secondary data. That's also a message. Don't try to collect all the data yourself. Now you need to work. If you work at systems level, you cannot collect all the data. So you have to capitalize on things. So interesting that's a rank distribution of the food availability index. So you see that everybody that's under the dotted red line is food insecure. And you can see the structure of things when the farm started to get more food secure. And of course, self-consumption is still remaining more or less the same. It still increase, but you have a much more other opportunities. So you usually invest in livestock, and very important in farming systems in Asia and in Africa. The black dot off-farm activities are off-farm labor, but also remittance that people get by going into seasonal migration or permanent migration and sending money to their family. So this is, migrations are really key in maintaining the rural areas in Africa and in other places like Nepal. Another interesting paper that was done in Guatemala is not looking at quantity but also at quality. So the traditional farming systems in Guatemala are called milpa. It's usually the most important crop is maize, but around that maize you can have 5, 6, 7, 8, 9 other crop species. And there was a project funded by USAID, and they made some survey, but they didn't know exactly what interventions and which objective they had to do. So we use the survey data that was done in a previous project, and we did an analysis both on the quantity and the quality of the combination of milpa system. So it's at the field level, but it did bring a lot of information about the natural quality of the different combination of systems. That's a multi-criteria analysis. I'll go quickly through that. Trade-off, very classical example in conservation agriculture, in crop livestock system. Conservation agriculture is 3 principles. It's no tillage or minimum tillage, crop residue cover, permanent crop residue cover, and rotation. And in many systems, livestock are more important to farmers than covering the fields. So the trade-off between crop residue and livestock feeding can have dramatic effects in some places where you promote no tillage, but you don't have enough residues to cover your soil. You do increase the erosion, because initially the conservation agriculture is to conserve soils and conserve moisture in the soils, but it works only when you have mulch on those soils. I think that's a good example. We were involved in that research. A very good example on the policy dimension of things and the interconnection between policies. So this is the part of the Indo-Gangetic plains of India. It's the breadbasket of Asia. That's where the Green Revolution took place. That's where production really increased and permitted to sustain increased population in India, but feeding the people more decently than they were in the past. But you know also that in India, there's a lot of air pollution, and part of it is linked to those systems, rice wheat systems. And why? Fields are cropped almost 365 days a year, and it's a sequence of rice during the monsoon season, hot season, rainy season, and wheat during the cold season. And in 2009, they had a water law, and they wanted to save water because the water table was going down and still going down there by almost 1 meter per year on average, so it's quite big, because you have subsidies to pump and so on. So they wanted to delay the planting of the rice, that the monsoon is well established and that we are saving water from the ground table. But the problem is that we postpone the harvest of the rice. So if we postpone the harvest of the rice, we postpone the sowing of the wheat during the cool season, dry season, irrigated wheat. And if we do that, the wheat comes at flowering when temperatures are becoming too high, and you have a strong yield penalty. So what did farmers do? You can see under those figures between the difference in pollution between the period 2009-2015 and before. What the farmer did, they wanted to still plant the wheat as early as possible, and the incentive was just to burn the straws. And so you increase the pollution. So that's a link between the water policy and pollution. That air pollution, you would never imagine that it would have that effect. And of course, you know, crop residue burning, it's not only the only source of pollution in India, but during the months of October, November, December, it's a major contribution. And in fact, if you look at public health issue, many lives are lost every year because of that. So we were looking at alternatives to crop residue burning, and that's so going to the problem to a solution. And we've been developing a special combine harvester. A special combine harvester, and then you can see on the left side, that's in the months of October, November. On the left side, it was harvesting the rice, and there it's planting the wheat through mulch. So it looks very simple, but I think to go through that depth of mulch, you needed really good mechanical engineers to develop that. And you can see that was added to the combine harvester. It's an additional system that threshes the rice in a smaller fraction. So that's really an engineering solution to a problem, major problem. If you look at how much burned area we have in the state of Punjab and Haryana. Punjab is a bigger state, so more a burned area. But you could see that from 2001, it went to less than 500,000 hectares to more than almost 2 million. And what is good, and I don't know, we have not done the attribution yet, but you can monitor with remote sensing, and that's the evolution of the area, the fire detected through remote sensing. This is the burn area. That's a different sensor that is looking at the number of fires detected. And you can see a drastic decline from 2023 to 2024. So the role of data also in monitoring is important. I will go through indicators metric very quickly and will not go to that. Just a few words about Raphael, how long can I talk? Raphael? It's up to 8 o'clock, no?
Yeah.
I'm joking. I almost finished.
Have 10, 15 minutes.
Yeah, no, I will finish very soon. So let's go back to UM6P. We created... Huh?
It's your inspiration that counts.
Yeah, no. It's late also. Huh?
Yeah.
It's,
Late inspiration.
yeah. So let's go back to UM6P and what we are building here in the field of agriculture and environmental science. And I think we're very good and generous funding, but we created a lot of disciplinary units. And right now we have very little systemic or systems approach to what we do. So something that we want to create very soon is a Center for Applied Systems Analysis. And we don't want to recruit many people. We just want people to work together within the college, across the university and the ecosystem, and also beyond that. So that's, and I hope it will be created within the next few months. So those are the pillars, and I think it's very important to give systems vision to students as well. Very important that students are good in their discipline, but also that they have that broad knowledge of things. And the policy dimension is something I really believe in. If we want to make changes, it's not by working with few farmers. That's where you gain your knowledge, working with farmers. But if you want to have impact at scale, you need to go through policy, and you need to go through private sector. Public-private sector is also key for that. And I will not go in detail to that, but I think we have few ideas already to on research work ongoing, like everything related to biomass valorization. We have very good, interesting lab work, but we don't connect it to value chains. So if we want to have solutions, I think we need to include value chains as well. And I think we can probably have many other ideas. It's a question of having priorities. Will work, I think, IAS has been a source of inspiration in somehow, because we don't want to put a lot of resource on having people working there. We have already professors at the university, but we want also to have an open approach and have people coming here to work on specific systemic problems. And we want also to be able to improve the quality of research proposals by giving a more systemic vision of things. So that's the community of practice, and Jacques has been the leader for that with Catherine the Skemaker and Wagening. And we had the first workshop in Morocco exactly a month ago. People like to put labels on things. And sometimes you have a label on the box, and when you look in the box, it's either empty or it will look the same. So I'm and you probably, the last Science Week, Fouad, Ken Giller was very clear about that. So sometimes it's good to use words, but sometimes I'm very cautious. I'm more prone to principles than just the label you can put on things. That's the T-shape we want to give to our 5 years engineering degree, which should start in September, inshallah, if we get the accreditation, and we're almost ready. Jacques is here to help us also on that. So. But again, to have that disciplinary dimension, but also having that coating in terms of social science, socioeconomic, economics, data science, and also teach people or have young people starting to work across disciplines very early and looking at systemic things. I think I'm almost finished. That's a paper we wrote when I was working for a good, large public institution, the CGIR, that was CIMIT. And I was really starting doubting about what we were doing, because we were always project funded, and we had, funding for 4 years to do something, and then we had to go and get funding to do something else somewhere else, without having a programmatic vision. I mean, we tried by having our own strategy, but donors sometimes were like that. And Jacques worked for ICADA. I think you had probably the same feeling, Jacques. And that because we were working on projects of 3 or 4 years, vision of success, indicators of success were just not meaningful, because they were just measured at the end of the project and nothing projected in the future. So that's why we wrote that paper. Many good points there, I believe. A catchy sentence: project never fail, project never scale. And thank you very much. That's the place where we need probably to build a multidisciplinary research center in co-development with the population, co-construction with the population. Raphael, that's there you want to go at some point.
Which country is that?
That's Morocco. That's the IATLAS.
That's Morocco.
Wonderful.
He said Morocco.
It's not Tibet, it's not Vietnam.
No, it's Morocco.
He said Morocco. It's
Which area?
Exactly.
It's the high plateau west of Toubkal Valley. It's about 2,100 meters there. That's where we had the field trip when we went to that when we did that workshop. And that's a place I return very often because it's very inspiring also.
It's kind of a secret place.
Yeah, I never give the location.
Yeah, I know. It's what you said.
Now, if you go to the website now of managed by Jacques, you'll get the location.
For a long time, you actually avoided to give the exact location.
It's
What
like
you told
that.
me.
When you have a treasure, that's what you.
Of course, of course.
Can I ask a question?
Now it's not that you can ask questions. Now it's going to be the debate. No, it's going to be the debate, and not only questions. Just because some people they think they need to ask questions. But it's not only a question of questions, it's a question of saying what you want to say. So go in, shoot.
Not a question.
Some people.
No, but I'm already, that's the word. I'm already thinking about Science Week 2026 because the theme which was actually suggested by Raphael, convergence, is about how different disciplines can converge, talk. My question is this, because if you have 5, 6 different disciplines trying, you work together to solve wicked problems. So you come from different disciplines. Don't you need to have at least a basic knowledge of almost every discipline? Why I'm saying this? Because I'm trying with Mohammed Ben Kamoun, I'm trying to to actually implement this idea I have to have a circle of disciplines that absolutely every student should know something about sociology, anthropology, engineering, mathematics, etc. Otherwise, how can you actually understand each other when you are coming from different disciplines? How can you solve a wicked problem if you're talking to an anthropologist and you have absolutely no idea what the hell is he talking about? So that's my question. Or that's my contribution to the debate.
No, it's a very valid point. But even if you know the other disciplines, you have the respect and you have the understanding of the other discipline because you are looking through different lenses, you know, and you're not the way you are trained in your discipline. You just have some distortion in how you look at problems and solutions. And that's what we want to do. And in that degree, we want to do as young as possible. But of course, you know, you will have a shallow understanding. But the most important thing is just recognize the importance of the other discipline.
That's the point.
Because, you know, I work all my career and I work a lot with plant breeders, and they thought that they would solve all the solutions with plant breeding. Jacques, isn't that true?
Yeah, but there is this point in science where you need to be specialized in order to really make a real contribution. But in the same time, what you are talking about, I think, is to get the languages of the different disciplines. You don't need to be specialized in the other disciplines, but you need to understand the language of this discipline in order to share what you have to say.
But more than
not possible.
more than the language, huh?
Some basics.
Yeah.
What I'm meaning, the language can be really deep. For instance, when you're talking about mathematics, knowing the language is basically knowing mathematics.
Yeah.
Yeah.
Well, you can apply that for
all the
physics, astronomy. Yes.
What I mean, but you know, there are different levels. But if you don't know the basic language, you don't know the basic logics of the disciplines.
Yeah. But that can be done at the individual level, but collectively as well. You know, we never talk about, I mean, we take that as deep and broad as an individual characteristic, But it could be for a research group to be deep and broad, and I think that's what we want to do. Being more collective in the, because you don't need everybody understanding everything, because you don't understand anything if you do that.
No, I just wanted, yeah. Can I contribute also to this? No, in the sense that I think the education is not well equipped to go where we all see that we need to go to solve these complexities, because we do need interdisciplinary thinking and many others. But like, just as you think how they train us as PhDs, like we are all by ourselves doing research in different countries, doing field work. It doesn't make any sense. It's completely disconnected. Anyways, this was my point, and I don't know if you see that. And then, so what does it mean also to train, for instance, PhDs in this new direction? And then again, the challenge of, as you also were mentioning, we need the disciplinary expertise and then also move towards interdisciplinary or even transdisciplinary. So how do we train then the students? You know, it's really dilemmas that I have.
And I think there are different schools for that. And again, you know, take the analogy, when you build an airplane, you rather have somebody who knows a lot about the engines and not understanding anything about the seats. So it's a collective way of putting expertise together. Yeah. And I mean, if you look at social insects, it's like that, you know, they have functions. So maybe they don't understand each other. I mean, that's a school of collective intelligence. You know, it's how you articulate things, but you certainly need to give the chance to have a more holistic vision of things. If not, you end up by listening to very stupid solutions to complicated problems.
But because I still have friends, or like younger friends who are doing PhDs in Sweden, in Norway, the US, and they're still doing PhDs like as a solo, how you said it, a solo.
By themselves, yeah.
By themselves. Yeah.
But it's very difficult. I mean, that is again, you know, if you talk at, let's talk about PhD, but let's talk about scientists as well. Yeah. It's much more comfortable to work in your area of expertise and publish if your indicators for success in your career is publishing. Don't go into that because it's more complicated. But if you want to make a difference and try to start looking at the impact of your work, I think you need to go to that. And it's not everywhere, you know. I have a full respect for narrow disciplines that are very good. I mean, it's just, you know, if you look in medicine, it's the same. And that's the hospital that is putting those things together in a meaningful manner. So it's a not only, because that's the community of practice we are discussing now. Some agronomists label themselves systems agronomists. And it's becoming a discipline by itself, unable to discuss with economists, with anthropologists, with sociologists, thinking that they have the vision of the system. And for me, it's a bit of a danger.
Yeah, it is. Yeah, but you know, the systemic vision of complexity and all that becomes a danger, I think, because people in their specific discipline, they all think they have the systemic vision because it's becoming so fashionable that they pretend that they have the systemic vision, but in fact they are specialized in their way to understand what is supposed to be systemic in their specific field. You know what I mean?
Yeah, we're still with the elephant.
Exactly.
Oh, thank you, Rafael. Thank you, Bruno, for your nice talk. So you mentioned something related to one of the important technology that we are developing. So for the good agriculture is the remote sensing. I know that there are some colleagues with Abdelghani, they're working on that. So there's a center dedicated to that in here in UM6P. But just I want to understand a bit about the vision of UM6P toward that. So we know that we have enough data about our lands in Morocco, so how this agriculture is developing. I know it's expensive, or we need to develop with the industry, so to build our own satellite to look to our lands. Or this is something is not in the scope of the UM6P activities and development for now, for the future. Because I think it is very important to have enough data on our lands, how they are doing, how they are developing, given the stress that we are having here now in Morocco. So there is any signs in this directions?
No. Well, of course there is. I didn't have time to talk about the strategy. We took one full year in 2022 to develop our strategy for the college, because we came with different building blocks, and some of them were doing very different things, and we were trying to build horizontality, transversality in that. And the first step was to look at the strategy. So water in Morocco, climate change in Morocco should be priority number one. We have to realize that a lot of the agriculture, rain-fed agriculture, is family farming in Morocco, and it's very important. A lot of the small farms are getting less and less access to water, and it's very important. So it's a question of livelihood. So we want to work on that, but we don't want to exclude, because if you look at the water problem in Morocco in agriculture, large farms are somehow responsible for extracting water and moving around. I mean, small farmers, they don't have the luxury to, once the water table is dry, to go somewhere else. And they are, locked to the land. Yeah.
Other comments?
So, and on the remote sensing, of course, we have a lot of things now we can do. Again, in Morocco, which is very important, is to link what we do and the knowledge we generate with policy dimension of it. And we are not policy makers, but a lot of evidences can be used at the policy level.
Question, comments, discussion?
Dinner?
Fine. Dinner? Yeah. Let's go. Thank you.
All right, thank you. Thank you for coming. And
Pleasure.
and thank you for inviting me.
A pleasure.